Then integer data type depends on target platform. They vary. The range of integer data type will vary. Probably it can be like for n-bit controller, you can find this is the formula 2 power n minus 1, 2, 2 power n minus 1 minus 1. Right, actually, for a range is 2 power n minus 1. I think from the minus, yeah, something like this. Minus 2 power n minus 1, 2, 2 power n minus 1 minus 1. That is how it is. Like, depends on the controller. You can replace the n with that number. If you replace uh, 16 with that one, according to that, you will get the range. Right. Short data type that we have in integer, right? So which is half of that of the integer, right? And then the long data type will be 2 times integer. If your integer is only 2 byte, your long can be 4 byte. If it is 4 byte, your long will be 8 byte, something like that, 2 to the time. This is common pattern in which these data types will have the range, right? Most of them are like that only. There may be some exceptions, but there are those are few. Most of the controller follow the same thing for integer, short and long, right? So when you want to represent an hexa number, prefix a 0x with that so that that number becomes a hexa number. If you want to represent an octal, which is a base 8, you can simply prefix a 0. So prefixing 0 will make that number as an octal number, right? And for decimal, you no need to prefix with anything, just feed a number. Right. That will work. So let us
Sir,
inspect.
for 8-bit controller,
Hmm.
so this is the range, sir. Range of the
Range of the integer. So that you can do.
okay.
2 power 8
Sub.
minus 1. Minus 2 power 8 minus 1, 2 plus 2 power 8. So from this, what we come to know, is it like we cannot go beyond that range? No, we have an option, right? Long data type, use that. And so you can have a more coverage, 32-bit coverage. Sorry, a 16-bit coverage. Like that, you have to decide what based on your controller bit size, data bit size, you can decide their range for integer, short, long for those. But
Usually for the programs, we will be using both signed and unsigned, or mostly it will be unsigned, sir.
okay, it depends on the program that we do. Let us say if it is an temperature, engine coolant temperature, there are certain physical quantity which comes in negative, ambient temperature. Like that, we have many parameters now. So these physical parameters will have a negative value. In this time, we will go for negative. There are certain parameter which cannot have a negative value. Example, engine RPM, vehicle speed, wheel count, tire pressure. So these things will not go in negative. So in those cases, we can use only unsigned. So it depends on the physical quantity for which you are doing programming.
Okay. And one more thing here in the in the formula they are given minus, sir. So when we like calculate for 8-bit, it's or minus.
So it is like this. This is the range. Actually, from here to, you can say like this.
Okay.
From minus 2 power 8 minus 1 to 2 power 8 minus 1. After getting that result, you subtract 1 from that. So it is in that way.
Okay. Minus 128 to minus 127, like that.
Yes, plus 127. Minus 128 to plus 127 if it is an 8-bit controller.
Okay.
Got it now?
Okay, for signed only. For
For
signed.
signed, if it is an unsigned, you can go from 0 to 255 maximum
Okay.
right now. So
Yes.
it is in that way. Data type modifier, short, long, signed, unsigned, volatile, auto, static, register, const. Most of them I explained. While I am explaining basics, I covered most of them. So, right. Let me ask some questions to you so that let me ensure that your understanding is perfect with respect to these things, data type modifiers. Right. What is mean by signed, Amir? When I will use signed keyword in C programming or embedded C programming?
When the values when the values require both positive and negative, we'll be going with signed and sorry.
Because when can we go for this static variables?
Uh, Static basically um, used to like not to change the variables whenever we.
Not to change, no, it is not to change the variable. It is not to, we don't want to change the memory location in our entire program.
Yeah, it will be like the variable will be from running will be there until the end of the program.
Yes. So if that actually the static variables are global variables only, but limited scope. The problem here is, let me explain you how beautiful the actually how what the really the static variables are. Right. For that, I let us do an experiment here. Because mostly people make mistakes in this static var.c. See, I declared, I use the usual thing, so include stdio.h and then int main of, right. So here I declare a variable. I declare a variable as static int num equal to 10. Right. So here I have a function called int add of x comma y. They are of type int. Right. Question is, so I just use add. They return x plus y. Right. So I just say num, comma, some 20 as the result, and I do sum equal to int sum equal to add of num, comma, and 20. Right. See, can I use this num? Actually, when I declare int static in num, it is using not using the stack, it using is rest of the RAM and declared from the when the program start executing, by the time itself this variable is created. Right. So after that I create a variable called sum. Then I assign sum equal to num comma 20, something like that. Right. Why don't they use this as it is global when it is also created during beginning of the program execution? Why I have to pass it to X? I can just say I can just actually when you look at the program execution, when they pass this num to this function, they make a copy of num. and we'll store it in the variable called x. The x is stored in the stack memory. And then the 20 will be copied to y, right? Which is also a location, memory location in a stack. And they add those two variables and return the result. That's how it works. The question is, as it is a global, why don't they directly use num here only by passing y? We can do like that, no. If I do like that, it should work because from the day one, from the starting of the program execution, the num is there in the memory until it reaches this point. That means line number 8. Only pass y to that, and then you do the addition. They can do like that also, no? Why we are not doing? Why it won't work? If I execute this program, it will end up with a error because the num is not accessible outside main, but it is there from the beginning of the program execution. So that is called the scope of the static variable is it is available. Though it is there in the memory, the people cannot use this that num outside their scope. That means it is declared inside the main. We cannot use it outside the main. If they are declared inside the add, we cannot use them outside the add. Do you understand the point? Right. So that's why we are saying we are passing it to this. Right. Let us run this program and understand the thing, what really happens. Printf sum equal to %d, then we pass our sum. This is perfect. Right now. Okay. This will give the result. Come on. GCC static var dot c hyphen o static var dot exe. They throw error. Why? Maybe I don't have a space here. Okay. Function add implicit declaration. Okay, we don't have a prototype. That's why they are complaining. Int add of int comma int. Okay, so now I just type static var. I get the result 30. Perfect. So now I want to try my logic. Just pass 20 and accept only one argument. And I try to use num here. That means because I was told like num is there from the beginning of the program. If that is the case, it is a global. So I'm trying to access it in this function. Let us see what happens. I get the error. So undeclared identifier is reported only on once for each function it appears in. So they say we do not know what the num is. So they are doing it. So, they are reporting that as an error. Now from this what we come to know the static is within the function it is used. But is it there from the beginning of the program? And if it is there in the beginning of the program, why we are unable to use it? Because the scope is limited to that. Now what I do, I just move that from here to here. Right. So I just say num plus 1. Okay, I just call num plus y. Why don't we do num plus y? I declared here and I pass that, right? So I just call sum equivalent to, I just pass y to that, and so that they will add the result and will print, I will get it right now. So let us do that and check whether we are getting the same result. Yes, we get same result. Now if I call the function with, it is 20, it is assigned to that one. Maybe we can increase the num. After we add that, we return it num plus plus. I just increment a num by 1 and then I add it. Right. So if I call the same thing with a different number, what will be the result? Maybe if I declare that with 30, right? So first case, value of num is 10. So 10 plus 20, I have to get 30. In the second case, num is 10. The value of y is 30. So I have to get 40. Agree, both of you? Maybe I have incremented here, but I think that incrementation doesn't make any sense. I do the incrementation post increment. They will add the value first and then only they will increment the num. See, the first call, they call add with the value 20. They come here. They assign the value 10 to num. Then num plus y. 10 plus 20 is 30. They will return it. After they return it, before they return it, the value of num will be incremented to 1. But that doesn't make any difference. The value of num is currently 11. Right. Now we have a second call. In the second call, we have the same function, we are calling it with input 30. Now the num value is 10 again because they are initialized 10. 10 plus 30. Again, we have to get 40 and value of num will be increment to 11. That doesn't make any difference. Can we think like that? Will that work in that way? Or it will work in a different way? If it is different, let me explain what is the difference.
I think it will not increment, sir. Num will not increment.
You mean to say you will get the same result? See, I passed 20 to add, right?
Yes.
Then moment I call it, they will come here. The value of num is 10. When I add 10 with 20, I get 30 as the result. I will print that. After I am doing it, I also increment the value of num to one step. So the 10 will become 11. Both of you agree about it or not? Yes or no?
Uh,
While we are printing sum, what will be the value? It is 31 or 30? Come on.
31.
Let me comment this. Let me comment this. We'll come back to this later.
It will be 31, sir.
Why? The increment is post increment. So they will perform the job first. The precedence is this one is very low. So they will do the addition first and then only they will increment it. That is how it will work.
Okay.
Right now. Maybe. As I have added a bracket, they may do differently. Because this bracket will give some sort of important. So let me do like this. So I just run that. Perfect. So now I make a small change. I add a bracket. It is thinking a lot. Is it hanging? Okay. We get 30 only. After thinking a lot, it come up with 30. Okay, perfect. So now this is working. So what will be the result of this one?
41 answer.
41. Are you sure?
Yeah. Yes, answer. I think for starting, once if it is declared, it will be available.
Brilliant. Actually, the result will be 41. Let us see that. See, it is 41. Initially, is it 30? It is 41. How that works? Come on.
So post increment, the num will be incremented to 11.
Okay. When we call the second time, we have a initialization here. No, that num again will become 10, right? Why it doesn't happen? It should become 10 again. As we are doing an initialization to num, though it can increment in the first call, it can increment to 11. True. When we call the second time, as we have an initialization routine, it should initialize to 10. Okay, it doesn't happen. Instead, it keeps that last increment value and directly that is the 11. It add 11 with 30 so that we get 41. Why that happens? I told that static is a variable which is declared in the rest of the RAM and is available in your entire program, but it is available in the scope in which it is declared. Perfect. So I have a global memory RAM. There it is num is declared and initialized with value 10. Perfect. And I call add first time. So they come here. Very first time as they are encountering the symbol num, they check the RAM whether it is there. It is not there. They declare that num in the RAM and initialize with the value 10. Perfect. And then we return 10 plus 20, which is 30. After doing it, we also increment the value of num to 11. So the memory location, in that memory location of num, the value will be 11 now. Okay, after that, we again call the same function with an additional different value 30. Now the value of y is 30. We come here, this time, the second call time, they will look for this variable, whether this num is already available in the memory or not. Yes, it is available. Because declared, variable declared in the memory, if it is a static scope, it is a storage class, it is there forever in your entire program. Still the program is not over. So they look for that variable, it is there, so they won't do the declaration and initializations. They will simply ignore that line. Why they are ignoring that line? That variable is already there. The property of the variable is its survival time is survival of the program, the time survival time of the program. So they don't do it again. Though you call the second time, they will ignore this line. See how program behave differently in different time. So as the current value of num is 11, they take 11 and add 30 with that one. That's why we are getting 41. Clear now? Now I am making a trick. You have to tell me the result now. Maybe can tell. What will happen now? Every time will I get the second, if I run this program, what will be the output? First time, what is the output? First call, what is the output? Second call, what is the output?
First time it will be 30, sir.
Okay, second time? It is
Second
41
time
or
40, sir.
40.
Yes.
Why it is not 41?
Because again we are assigning the number. Again we are the first time it will become 11.
Here also they are assigning. Here also they are assigning. In the second call, they ignore this, but they take this into account. Why?
Because it's not a declaration, sir. It's
Brilliant, brilliant. Thank you. This is a reinitialization. Though you declare that variable as static, so okay, when you call add 20, they come here, they look for num, it is not there, they declare num with 10 and then reinitialize the num with 10 and they add 10 with 20, they get 30 as the result, they increment the 10 by 11, okay. In the second call, we pass 30. When the 30 comes, they will come and look for the first line. So the variable is already there, they will only ignore that line. Declaration line will be ignored. So, but in the line number 17, we have a reinitialization step that will happen. So the 11 will become again 10. So result will be 10 plus 30, 40, and then the num will also increment to 11. That is useless because this increment 10 doesn't make any sense because we reinitialize every time with the 10. If you are not doing this reinitialization, then it has a, so in different times, depends on your requirement, you have to use the static variable appropriately. If there is a reinitialization required, you can explicitly reinitialize it. If not, just you can leave it right now. So when let us see whether what we told really happens in this case. Right now 30 40 because that reinitialization happens. Clear? So from this example, what we conclude is static is a variable. Static storage class declare a variable not in the stack space, outside the stack space. Though it is RAM, it is different. Perfect. That is first step. So the static variable is available throughout the program. Right. That is the second thing that we understood. Once you declared, you need not re-declare it again. That is what the thing. The third one is static is available within the scope in which it is declared. If it is declared in the main, it is available only in main. If it declare in the child function, it is available in only in child function. Right. That means your this user defined function only in that it is available. Though it is global, we have that limitation with static. Is that clear to you now?
This one, sir.
Right now.
Yes.
So we can end today's session with this. We can proceed to discuss other point tomorrow. Is that okay?
Yes, sir.
Yeah, okay, sir.
Okay, team. So any doubt you have in today's session and whatever the discussion that we had up to now?
No answer.